Hey guys, today we're going to look at how to find the derivative without necessarily having to go through that whole limit process that we did in the previous lesson. So before we go ahead and examine on how to do that, I want you to have a look at these two examples. This first one, f of x is equal to 2x plus 1, is clearly a linear function. Now the derivative, remember, is the slope of your tangent line. For linear functions, the slope of the tangent line is equal to the slope of the linear function. So therefore, if I were to look at this slope, we can see that this is an mx plus b form. So my slope here is 2, meaning that the derivative f prime of x is equal to 2. Now for constants, right, so f of x is equal to 2, we just have a horizontal line. And the slopes of all horizontal lines are equal to 0. So following that logic, if f of x is equal to c, where c is any constant, then the derivative would be f prime of x is equal to 0. Now let's have a look at some other examples. We have this first one, 3x squared minus 2x plus 3. If I wanted to find the derivative of that and I were to use the limit of the difference quotient, that would take a really long time. And simply because you would have to plug in x plus h and then square it and then subtract f of x and combine like terms and then figure out a way of factoring out the h, and it's a lot of work. So we're going to do a little shortcut. I'm going to find all of these derivatives here using what's called the power rule. So in class, what we did was I did some of these questions and then I asked you to find the pattern. But by now we've already kind of done that, so I'm just going to go ahead and state it. So for f prime of x, my derivative here would be 6x minus 2. And that is because what we do is we take the exponent and we multiply it with the constant, and then we subtract 1 from the exponent. With the minus 2x, remember the exponent of x is 1. So if I multiply that with 2, it's just 2. And then subtract 1 from the exponent, right, we would get 0, meaning there would be no x. So that's why it's 6x minus 2. And then the plus 3, we just learned that the derivative of any constant is 0. So if I were to find f prime of x for the next function, following that same pattern, if I multiply all of these exponents to the coefficient, we would get negative 15x, and then remember you subtract 1 from the exponent, plus 4x, and then minus 3. For this next one, f prime of x, the derivative would be, this would be 0, and then 3 times negative 3 is negative 9x squared plus 24x to the third. Now you can apply the same thing even if you have negative exponents. So this negative exponent, negative 2 times negative 1, is a positive 2x, and then subtract 1 from negative 1, you get negative 2. And then you do the same thing for 3x raised to the negative second power. We would get negative 6x raised to the negative 3. Now with fractions, okay, you're going to have to take that 2 over 3 and multiply with 6. As a little shortcut with fractions, when you have a rational exponent, because that's what that is, whatever the denominator is, that's what you're going to divide the coefficient by. So 6 divided by 3 is 2, and then multiply with the numerator, which is 4. X, and then remember we have to subtract 1. When you're subtracting 1 from an exponent that is a fraction, just look at the denominator. So minus 1 would be minus 3 over 3. Since my denominator is 3, 3 over 3 is 1. So 2 over 3 minus 3 over 3 is negative 1 over 3. And then minus 8x to the negative 3. For this last one, f prime of x would equal to, and we take that negative 1/2 and multiply with the negative 6, which is the same thing as saying 6 divided by 2, so 3 since the negatives cancel, x, and I'm going to subtract 2 over 2. Negative 1 over 2 minus 2 over 2 is negative 3 over 2, plus 3 over 2, since I can't divide 3 by 2, x, and then also subtract 2 over 2, so minus 1 over 2 for the new exponent. So like I mentioned, this is called the power rule. Now, so that you understand the proper notation, you'll see here d over dx. This is an operator. Much like adding, subtracting, multiplying, dividing, the addition symbol would be considered an operator, meaning add this function. So d over dx is the operator that means to find the derivative of whatever is inside of that bracket. So the derivative of x raised to the n, right? This would be your general rule for the power rule. We take the n and we multiply with whatever coefficient is in front, so n, and then times x, and you would subtract 1 from the exponent, so n minus 1. Now this is important. In order to be able to apply the power rule, your function must be written in polynomial type form. So these are examples here. These are expressions that are in polynomial form, versus these that are not in polynomial form, but we can make it in polynomial form so that we can use the power rule. So sometimes we'll have to be forced to rewrite the function so that we can use this power rule. So let's practice with a couple of questions. So f of x is equal to 2 over x squared minus 4x to the third. This is not in polynomial type form, but we can rewrite it so that it is. If I apply my rules of exponents, when I have something in the denominator and I would like to bring it up, you just make it the exponent negative. So f of x could be rewritten as 2x raised to the negative 2 minus 4x to the third. Now this is in polynomial type form, so I can find the derivative. So f prime of x would equal to negative 4x to the negative 3 minus 12x squared. And if you can, right, and just to practice, we can always rewrite this using only positive exponents. So the negative 4 would stay in the numerator, but since x has a negative exponent, that's going to go down to the denominator, and then you can make that exponent positive. So negative 4x to the negative 3 is the same as negative 4 over x to the third. And then, of course, minus the 12x squared. For this next one here, we have a quotient. 3x to the fourth minus 3x squared minus 2x, and everything is divided by x. Since we are only dividing by a monomial, meaning one term, you can basically take each term in the numerator and divide it by whatever is in the denominator. Since we're dividing, that means that we're going to have to subtract the exponents of x. So I'm going to rewrite f of x as 3x to the third minus 3x minus 2. And now I'm ready to find the derivative. So f prime of x would equal to 9x squared minus 3. For this next one here, you'll notice we have a bunch of factors. We will have to multiply everything together. So f of x would equal to, I'm going to multiply these two first, which would give me x squared plus 5x plus 6. I get that once I FOIL and combine like terms. X times x is x squared, x times 2 is 2x, plus 3x, which gives me that 5x, and then 3 times 2 is 6. And now I need to multiply that with 2x plus 1. So I'm going to distribute that x squared, distribute the 5x, and distribute the 6. So f of x is going to equal to 2x to the third plus x squared plus 10x squared plus 5x plus 12x plus 6. And now finally I combine my like terms. So 2x to the third plus 11x squared plus 17x plus 6. And now I'm ready to find the derivative, which would give me 6x squared plus 22x plus 17. This next one here is very much similar to the one that we did right above. We would have to divide every term in the numerator by x to the fifth, which again, we would just subtract those exponents. So f of x would equal to x, and then 3 minus 5 is negative 2, minus 5, and then 2 minus 5 is negative 3. So now I'm ready to find my derivative, which would equal to negative 2x to the negative 3 plus 15x to the negative 4, which we can rewrite using only positive exponents, and that would be negative 2 over x to the third plus 15 over x to the fourth. With this next one here, we have 3x over the cube root of x squared. When you have any kind of root, you can always rewrite that root as an exponent. As a reminder, the root is the denominator of the exponent and the power is the numerator. So I can rewrite this as 3x over x raised to the 2 over 3. And now I can divide these x's by subtracting those exponents. Since this exponent in the numerator is 1, that is the equivalent of 3 over 3, so that I can subtract that fraction. So f of x is going to equal to 3x to the 1/3. Now I'm ready to find the derivative. So f prime of x, 3 times 1/3 is the same thing as 3 divided by 3, which is 1. And then x, and I'm going to subtract 1 from the exponent. So I'm going to subtract 3 over 3, which is equal to negative 2 over 3, which you can rewrite as well. This would be 1 over x to the 2 over 3, which if we wanted to, we can also rewrite this using the radical, which would be 1 over, the 3 is the denominator, so that is your root. It is a cube root, x, and then the 2 is the numerator, so that would be the power of x. Last one here. This is already in polynomial type form, so I don't need to rewrite it. I am ready to just go ahead and find the derivative. So I'm going to multiply negative 4 with 3 over 4. Remember, the denominator is division, the numerator is multiplication. 4 divided by 4 is 1, and 1 times 3 is 3. So, and then we have the negative, so negative 3, x, I'm going to subtract 4 over 4, which will give me negative 1 over 4. Then 2 times 1/2 is 1, so plus x, and now I'm going to subtract 2 over 2 from that exponent, which will give me negative 1/2. Again, I can rewrite this using only positive exponents, which would be negative 3 over x to the 1/4 plus 1 over x to the 1/2. This could be an acceptable answer, but as well, we could also rewrite this with the roots. So negative 3 over x to the 1/4 is the 4th root of x to the 1st power, so x, plus 1 over x to the 1/2. The 2 is a square root. We don't need to write 2 in the as the root because it's implied, and then x to the 1st. Now we're ready to have a look at some other derivatives. Of course, in this class, we will be doing derivatives of trigonometric functions. So I'm going to introduce at least the 2 basic trig functions, which is sine and cosine. Now the derivative of sine is cosine, and the derivative of cosine is negative sine. Now if you have a constant in front of your trig function, think of that constant as like a tag along. It just kind of hangs out with your function. So I put here as an example, if you have the derivative of 3 cosine x, If you're trying to find the derivative of that, it would equal to 3 and then times negative sine x, which is the derivative of cosine, giving you negative 3 sine x. So we're going to put all of this together and see if we can write the equation of the tangent line for this particular function when x is equal to pi. As a reminder, the equation of your tangent line is written as y minus y1 is equal to m, which is your slope, times x minus x1. In order for me to write this equation, I need my point of tangency, which is what I'm going to start off by finding. You find your point of tangency by plugging in the x value that is given into your function. So I was given x is equal to pi, so I'm going to find g of pi. And that's going to equal to 4 sine of pi plus 3 pi squared. Now 4 sine of pi, the sine of pi is 0. So 0 times 4 is 0. So plus 3 pi squared would just be 3 pi squared. That means that my point of tangency is pi, comma, 3 pi squared. Now our answers don't always look cute, and that's okay. All right, so now I need to find my derivative. So g prime of x, and I'm doing this because I want to then find the derivative when x is equal to pi, which will be my slope for the tangent line. But first we're doing g prime of x. We need that general equation first, which is going to equal to 4. The derivative of sine is cosine, and the derivative of 3x squared would be plus 6x. So now I can find g prime of pi. So I'm going to plug in pi, so 4 cosine of pi plus 6 pi, which equals to, the cosine of pi is negative 1, so negative 4 plus 6 pi. And we would just leave it. This is my slope of the tangent line. Now that I have my point of tangency and my slope, I am ready to write my equation. So y minus y1, which is the 3 pi squared, is equal to the slope. Since the slope is an expression, I'm going to put this in parentheses, negative 4 plus 6 pi, and that is going to be multiplied by x minus x1, which is pi. And this is my equation. So let's try this a couple more times. We're going to find the equation of the tangent line to the graph of each of these functions at the indicated value. So we have f of x is equal to x plus 2 over x when x is equal to 1. So first I need that point of tangency. So that's f of 1, which is going to equal to 1 plus 2 over 1, which is just 3. That's my point of tangency, and if you want, you can write the coordinate, which is 1, 3. And I like to underline so that way I know, okay, this is the point I'm going to be working with. Now I need to find the derivative. But before I can find the derivative, this is not in polynomial type form. So I need to rewrite f of x, which, since everything is divided by a monomial, I just divide everything in the numerator by that. X divided by x is 1, plus now 2 over x, I can rewrite as 2x raised to the negative 1. So this is f of x, meaning I can now find f prime of x, which is equal to, now the derivative of 1 is 0, and then the derivative of 2x to the negative 1 is negative 2x to the negative 2, which for our purposes, since we're going to be plugging in a number, I'm going to want to rewrite that with only positive exponents. So this would be negative 2 over x squared. Now I can plug in that x value so I can find my slope. So f prime of 1 is going to equal to negative 2 over 1, which is just negative 2. So now I have all my information. I have my point, I have my slope, I can write my equation. So y minus 3 is going to equal to negative 2 times x minus 1. Moving on to this next one, we have g of theta is equal to negative 2 cosine theta plus theta squared over 2. And we want to find the equation of the tangent line when theta is equal to 0. So theta is just another variable like x. So first I'm going to find g of 0. So when I plug in 0, I get negative 2 cosine of 0 plus 0 squared over 2. The cosine of 0 is 1. So g of 0 is equal to negative 2 times 1, so negative 2 plus 0, meaning that my coordinate is 0, comma, negative 2. Now I'm ready to find the derivative. So g prime of x is going to equal to negative 2 sine of theta, since the derivative of cosine is sine, plus, now if I just move the 2, right, and I'm multiplying it to the front, 2 divided by 2 is 1, so it would just be plus theta. Now I can plug in theta is equal to 0. So I'm looking for g prime of, I put g prime of x. This is supposed to be theta, sorry. So g prime of 0 is going to equal to negative 2 sine of 0 plus 0. Now the sine of 0 is 0, so 0 plus 0 is equal to 0. So this is my slope. So although my slope is 0, you can still write your equation in point slope form and leave it like that. It does not matter. So y minus negative 2 would be plus 2 is equal to my slope, which is 0, parentheses x minus 0. So this, you can leave your answer this way. But if you want to keep going, we already know that 0 times anything is 0. So y plus 2 is equal to 0. Therefore, if I subtract the 2, y is equal to negative 2. Now, another important concept that we cover in this class is figuring out when you will have a horizontal tangent line. Now, I have the graphs here, and I'm going to explain what the graphs mean after we find out. If we are trying to figure out when there is a horizontal tangent, that means that f prime of x, your derivative, which is the slope of your tangent line, has to equal to 0, because all horizontal lines have a slope of 0. So if I were to look at this first example, f of x is equal to x cubed plus x, if I find the derivative, that gives me 3x squared plus 1. And I want to know when it has a horizontal tangent. So I'm going to make the derivative equal to 0. And then I'm going to solve for x. Now look what happens when I try to solve for x. I have to divide the 1. Subtract the 1. And then I would have to divide the 3. So at the moment, I have x squared is equal to negative 1 over 3. And then I'd have to square root. Now, when you square root a negative number, we already know that this is I, meaning imaginary. There is no solution for this, no real solution. And that's because horizontal tangent lines only occur when you have a minimum or a maximum. And if you look at the graph of f of x, it is always increasing. In order for you to have a maximum, your graph must have changed from increasing to decreasing. And in order for you to have a minimum, your graph must have changed from decreasing to increasing. And since my function does not change direction, it means that there is no horizontal tangent, especially since the derivative never equals to 0. That means no horizontal tangent line. Now in this next function, we have f of theta is equal to 2 sine theta plus theta. And we want to know when there will be a horizontal tangent between 0 and 2 pi, meaning through one full revolution of your unit circle. So we're going to find f prime of theta, which will equal to 2 cosine theta plus 1. And I'm going to make it equal to 0. And now I'm going to solve for theta. And how you do that when you have a trigonometric function is first you want to isolate that trig function. So I'm going to subtract this 1, and divide the two. So what I have so far is the cosine of theta is equal to negative 1/2. In order for me to separate the theta from cosine, we would have to apply the inverse of cosine to the other side of my equation. So theta is going to equal to the inverse cosine of negative 1/2, meaning that we are looking for the angle where cosine is equal to negative 1/2, which if you just look at your unit circle, the cosine is equal to negative 1/2 in two places, which is expected, and I'll explain to you why in a moment. But it is equal to negative 1/2 at 2 pi over 3 and 4 pi over 3. So these are my theta values, right? So theta equals where the cosine will equal to negative 1/2. Now look at where we have these two angles. Now I know that the axis here is only, it's not in terms of pi, but this would be considered 2 pi over 3, and this would be considered 4 pi over 3. So you see why I said that it was expected for us to have two theta values that would give me a horizontal tangent line. This is a maximum and this is a minimum. And horizontal tangent lines occur at your maximum and minimum values. So that's it. That's how you find the derivative and how to find tangent lines and horizontal tangent lines.